All right, this is our first lesson in our new equations unit, and this one is on writing equations. So our learning target is we want to be able to solve real-world and mathematical problems by writing and solving equations. So our I can statement is I can translate a phrase into an equation and solve it mentally. So those are going to be our goals today. So first we need to talk about the difference between an expression and an equation. Now, we've been doing expressions this whole last unit. An expression is just a combination of numbers and operations, and usually in our case it contains some variables. So things like 2x plus 8, 4y plus 17 minus 2w. It's an expression because we don't know what x is, we don't know what the variable is, we're not sure what it's supposed to be equal to. It's just kind of a chunk of a problem there for us. What we're going to be tackling now are equations. These are mathematical sentences showing that two things are equal. The giveaway is that you see that equal sign in a problem. So now we're actually going to be able to figure out what that x or that y is supposed to be. So some examples down here to jot into your notes. 5 plus x is equal to 13. So 5 plus some number is equal to 13. Or we have x minus 6 is equal to 14. So some number, we're not sure what it is, minus 6 gives us an answer of 14. That's something that we could work backwards and find our answer. So the main difference between an expression and an equation is that equal sign. We know what it's equal to, which means we can go back and find an answer. All right. When you replace a variable with a value, that makes it a true statement, a true sentence. That means you've solved the equation. Basically, you figured out what can I plug in place of the variable that would make this true. So look at our example here. 2 plus x, so 2 plus some number is equal to 9. Well, if you stop and think about it, if I have 2 and I want to add something to it to give me 9, well, 2 plus 7 is equal to 9. So we can check. The goal is to make both sides of our equation equal. 2 plus 7 is 9. 9 is equal to 9. So that means the solution to our equation, the number we could put in place of x to make it true, is 7. Nice simple one to get us started, but that's what we're going to be working with today. All right, so hopefully you hit pause. You got all of those terms and that chart filled into your notes because we're going to need it. So let's practice a couple together here. We're going to read our phrase, and basically as you're going along, I want you to kind of write some code along the way to kind of show you what's going to go where. So the first one is the quotient of 3 and y. So we know we're going to have 3 and y. And as we talked about in our expressions unit, the order they're listed in the problem is the order they're going to stay in your expression or your equation. But we need to figure out, what does the word quotient mean? Well, if you look at your chart, quotient is a word for divide. So that means we want to do 3 divided by y. Okay? So you're looking at that key word in there that tells you what kind of operation you're going to use in the problem. So next one, a number. Well, I don't know what that number is. So when you see a phrase like a number, that means that's your missing piece. That's your variable. So choose your favorite variable. I'm going to go with w. Then I have decreased by. If you look at your chart, decreased by is a way of saying we want to do some subtraction. We want to subtract by 7. So that's going to be our other piece. So W minus 7 is 15. Okay, if you remember from the middle of our chart, is signals that's where your equal sign goes. So equals 15. So some number minus 7 is equal to 15. Think for a second, what could that number be? What could I subtract 7 from and get an answer of 15? Well, our answer would be 22. 22 minus 7 is 15. And then our last one down here, the sum of a number. So sum means addition. A number, so that's our variable. So let's choose x and 9. So we want to add x plus 9. There's no is in this problem, so it's an expression, not an equation. We don't know what it's equal to, which means we can't solve it. But we just want to kind of find each of the different kind of code words or signals in the problem that tell us how to put it together. So let's do a couple of them together here. If you're starting to get the hang of it, pause, try some of them on your own, then hit play and see how you did. So the product. Product means multiply of 8 and k. So 8 times k, or even better yet, just write 8k is, that's my equal sign. So I'm going to put my equal sign here, is 40. So 8 times some number is equal to 40. Well, stop and think about it. In this case, k is equal to 5. 8 times 5 is 40. So we can even solve those equations. Next one, the sum of a number. So sum means addition. A number, that's when you put in your variable. So let's go with g. And you can choose whichever one you want. G and 22. So that means I want to do g plus 22. Remember, you leave the numbers in the order they were in the problem. Don't move them around. Then we have our is. That's where my equal sign goes. 40. So we have another one that's equal to 40. Some number g plus 22 is equal to 40. Well, stop and think. What could that be? What would I add to 22 to get 40? I bet you can find your answer. Next one, 15 minus y. So this one comes right out and says it. 15 minus y is, that's my equal sign, 9. So 15 minus some number is 9. Well, 15 minus 6 gives me 9, so that's my solution. Y is equal to 6. Next one, 18 oranges, 18, separated in 3 baskets. So think of 18 oranges and you divided them up into 3 different baskets. Okay, that means you are dividing. You divided by 3 is 6. 18 divided by 3 is 6. Well, that makes sense. 18 divided by 3 really does equal 6. So in this case, there's no variables, just a simple equation for us. Next one, less than. If you remember when you built your little chart, there's a little asterisk or a little star next to less than. Anytime you see less than, I want you to draw a little double-headed arrow over top of it. Yes, it means subtraction, but this is one of the rare times where you're going to switch up the order of the numbers in the problem. Every other one we've done so far, it's the first number goes first, the second number or variable goes second. Less than is one where we're going to switch it up. Here we want 4 less than a number. So we want some number, let's call it y, and I want to take 4 away from it. I want 4 smaller than that number. So in this case, the 4 is going to go at the end, y minus 4. Less than is the rare occasion where you're going to flip-flop the order of those pieces. So always kind of keep an eye out for it. And then last, this one, 4 more than 3 times a number. So there's a lot going on in this one. So again, kind of piece it together. More than, that means add. Oh, let me fix that one because it looks a little bit like my multiplication sign. So I'm going to add 3 times, now I got to multiply a number. Well, I don't know what that is, so let's call it P. So let's put the pieces together. 4 more than, or plus 3 times a number, 3 times p. So this is a two-part problem. We're not only multiplying our number times 3, but then we're also going to add 4 to it. But if you can read each statement and kind of pull out those key words, it tells you whether you're going to add, subtract, multiply, divide, then plug each of your pieces into the right spot. Remember that key for your equal sign is the word is.